Welcome to our webcast, The Need for Speed, Best Practices in Deploying EtherNet IP Networks, sponsored by Panduit. Whether updating existing systems or planning plant expansions, the amount of development and implementation rework time can be costly. A pre-built building block approach can reduce deployment time up to 75%. In this session, you'll learn how deploying an Allen Bradley Stratix 8000 or Stratix 5700 in a validated, pre-tested, integrated zone system enables your EtherNet IP network architecture, reducing downtime and cost. But before we get into our main subject matter, let's begin by going over the viewer panel. If you've participated in earlier control engineering webcasts, you may have noticed that we're using a new platform, so here are some of the characteristics. First, please make sure your pop-up blocker is turned off. This is an option in your browser software. You can use the Ask a Question box on the left side of your screen to type questions for the speakers during the presentation for the Q&A session at the end. You may ask questions at any time during the presentation. We'll get to as many questions as time allows. Questions that are for today's presenters will be answered verbally during the Q&A session at the end of the webcast. To download the presentation slides, use the event resources on the left side of your screen. To learn more about our sponsor, use the Sponsor tab at the top of your screen or click on the logo at the bottom of your screen to be redirected to their website. This webcast is being recorded, including the Q&A session. We will post the archive on the Control Engineering website in a few days, and we'll send you an email message with the link connecting directly to it after it's ready. If you're having any technical problems with the audio or slide presentation, click on the question mark at the right-hand corner of your screen to bring up a list of system checks to make before escalating to an online technician. If you're experiencing issues with the slides or audio, please refresh your browser or click the Refresh Media button directly under the presenter's headshot. You can control the volume settings of this webcast by adjusting the volume on your computer or by adjusting the volume on the webcast platform. If you need a technician, type the message into the Ask a Question box and someone will get to you as quickly as possible. Individual technical questions will be answered in the Answered Question area on the left-hand side of your screen. Here are our expert speakers for this webcast. Paul Herbst is the Solution Marketing Manager, Industrial Automation for Panduit Corp., a global leader in network and electrical infrastructure solutions based in Tinley Park, Illinois. In this position, Paul is responsible for pre-configured and integrated solutions for industrial automation market. Paul has responsibility for customer requirements, program strategy, converting technical positioning into key market messages in ongoing sales support. Paul has been with Panduit for 23 years and has experience in product engineering, product line, and product management, and most recently, solutions marketing. Focusing on integrated solutions, he has introduced new products consisting of Panduit and partners products that help organizations accelerate deployments while reducing risk and time to deploy. Mark Devonshire is a product manager for Allen Bradley Stratix Industrial Managed Switches at Rockwell Automation, the world's largest company dedicated to industrial automation and information, making customers more productive and the world more sustainable, and is headquartered in Milwaukee, Wisconsin. In his position, Mark is responsible for defining requirements, managing the product lifecycle, developing the managed switch roadmap, and future development requirements. Mark brought to market the first managed EtherNet switch from Rockwell Automation through collaboration with strategic alliance partner Cisco Systems. He continues to focus on the growing portfolio of managed switch products that use Cisco technology to offer a variety of features for IT and manufacturing professionals. Mark has worked in industrial automation for more than 30 years at Rockwell Automation. He started his career in the motion business and has held various positions maintaining a focus in product marketing management. 6 years ago, Mark joined the network infrastructure business and is currently responsible for the Stratix 5700 and Stratix 8000, 8300 industrial managed switches. I'm Mark T. Hosky, webcast moderator and content manager for Control Engineering since 1994. I have authored or edited scores of articles relating to industrial networking technologies. As a reminder, if you're having any technical problems hearing the audio or seeing the slide presentation, click on the question mark at the top right-hand corner of your screen to bring up a list of system checks to make sure to check before escalating to an online technician. If you're experiencing issues with the slides or audio, please refresh your browser or click the Refresh Media button directly under the presenter's headshot. You can control the volume settings of this webcast by adjusting the volume on your computer or by adjusting the volume on the webcast platform. If you need a technician, type a message into the Ask a Question box and someone will get to you as quickly as possible. Individual technical questions will be answered in the Answered Question area on the left-hand side of your screen. And now, Paul.
Hello, my name is Paul Herbst. I am a Solutions Marketing Manager for Panduit based in Tinley Park, Illinois. I'm happy today to be presenting along with Mark Devonshire from Rockwell Automation. The need for speed, best practices in deploying EtherNet IP networks. Today, we'll talk to you about best practices for deploying EtherNet IP networks on the factory floor and how our strategic alliance is helping bring greater value to the customer and improve efficiencies within the channel. So whether updating existing systems or planning plant expansions, the amount of development and implementation rework time can be costly. A pre-built building block approach can reduce deployment time up to 75%. Our agenda today will cover the business and solution trends, plan expansion or updates, zone systems, development and implementation requirements, and control panel examples and tools. We will cover how deploying an Allen Bradley Stratix 8000 or 5700 in a validated, pre-tested, integrated zone system enables your EtherNet IP network architecture, reducing downtime and cost. So let's get started. Mark, would you please start us with the business and solution trends?
Hi, everybody. If we look at manufacturing today, key trends are to be more productive, agile, and sustainable, meaning energy and environmentally wise. So if you look at your plant from the receiving, processing, packaging to shipping, and your entire enterprise from supplier to customers, from one site to another, what do these trends, along with challenges such as lower total cost of ownership, faster time to market, better asset optimization, and broader risk management mean? Well, it means basically network convergence, which is the ability to connect more assets and applications, be more highly integrated, and collaborate across boundaries. The idea or trend of industrial network convergence started many years ago, so it's not brand new. So to be more productive, agile, and sustainable through network convergence, manufacturers started to identify a couple of key needs associated with that. First is open network technology. And this is the broad availability of products, applications, and vendor support for an industrial-based system. Standards for coexistence and interoperability. Also, the ability to converge network technologies. So to move away from multiple network support to a single network architecture and support. Reducing the number of different networks and creating seamless information sharing across the plant-wide architecture. And also the use of common network design and troubleshooting tools across the whole enterprise. In addition, improved asset utilization to support lean initiatives. So things like reduced training, support, and inventory for different network technologies. And common network infrastructure assets. And also for this to be future-ready or future-proof to preserve your investment. So support for new technologies and features which allow for growth without major upgrades. The way to industrial network convergence is through a single technology, which is EtherNet IP, a standard industrial application level protocol. It enables the points mentioned earlier, so let's talk about some of these values. First is single industrial network technology across multiple different disciplines and applications. So the ability to support different types of applications from discrete, continuous process, batch, safety, motion, time synchronization, and also support asset configuration, diagnostics, and energy management. Also, you want to implement something that's established. And with the support of 300 plus vendors, this allows you broad availability of a diverse amount of products, applications, and support. And it also enables interoperability through required conformance testing. Also, it leverages standard network technologies. So it enables convergence between IAT and IT solutions, meaning the ability to support voice, video, and data on a common architecture, using common tool sets and common skills, and better asset utilization through a common single network infrastructure. It's also topology and media independent and needs to be portable and routable. So meaning it needs to offer seamless information sharing, again, something that EtherNet IP certified devices can do seamlessly over a common protocol, so no more data mapping, which this should simplify design and speeds integration. The advantages Ethernet IP technology enables is utilized in the development of the Converged Plant-Wide Ethernet Reference Architecture Design and Implementation Guide, often referred to as the CPWE. This guide, developed by Rockwell Automation and our strategic alliance, Cisco, is a set of network guidelines and best practices fully tested and validated by both Rockwell Automation and Cisco. The steps you see here listed are some of what you need to take into consideration when designing your network architecture outlined in the CPWE. This includes functional requirements, logical framework, physical framework, security requirements, and the use of standards and reference models. However, all too often, the third bullet, develop a physical framework, is overlooked. So Rockwell Automation's strategic alliance, Panduit, has reviewed the architectures and worked to create customer-ready solutions around the CPWE model. Their solutions are from the Unified Physical Infrastructure portfolio. And Paul is going to talk to you a little bit more about this.
Thanks, Mark. So as mentioned earlier, Panduit's Unified Physical Infrastructure development is well aligned to the CPWE architecture. We've broken down the industrial space into what we call the 5 Ns, in meaning industrial. These correlate to the zones or cells or levels of the CPWE model. As we look at the plant floor deployment, for example, Panduit has defined an effective solution, the integrated zone system, to deploy the network switches in the manufacturing and cell area zones. You can see this on the right-hand side of the presentation. These also correlate to the in-route and in-field space of the Panduit UPI. So what we've done with the integrated zone is it's part of a building block approach that Panduit defines for the physical network infrastructure. Throughout Panduit's unified physical infrastructure, there are similar defined solutions for each environment. enabling more effective Ethernet IP deployment from the enterprise to the control room, where the micro data center is found and shown here on the left, to the plant floor or the zone, and all the way to the machine control panel. This building block approach provides cost-effective, scalable, and easy to troubleshoot network architectures. And as we'll see more of, Panduit and Rockwell Automation are working together on integrated solutions to simplify deployment, reduce risks, and accelerate your deployment. So here is a brownfield application or a retrofit. So in this deployment, a network switch is being added to the infrastructure. The control panel is full of existing equipment and wiring. So what are we able to do to accomplish this task? A zone enclosure mounted on or near this control panel enables connectivity to this control panel. One benefit to this is that the switch, not being within the high voltage control panel, may safely be accessed by an IT person or other personnel. A managed switch in this case allows many layer 2 or 3 capabilities in this application. A little bit more about managed switches. They are typically more expensive than an unmanaged switch and require some level of support for initial configuration and replacement. However, as you'll see, managed switches provide many advanced features that enable better network performance in your control system. Managed switches are able to manage multicast traffic, provide diagnostics, data and security options, and other advanced features. So looking at this from another aspect, in this example, connectivity is required to be added to a control panel. An integrated zone system is mounted to support a cell or manufacturing area. A DIN patch box shown here is mounted in the control panel. The DIN patch box will patch in all the devices in that panel. This DIN patch box allows a test point and validation of the network with standards-based tests and equipment. So what this allows for is an improved troubleshooting with well-identified, structured connections that support staff can easily manage. So now we're going to look at choosing the proper network topology that can save in cabling complexity and costs. Zone architecture design is an efficient way to manage the ever-increasing use of Ethernet networks on the factory floor. This method, shown on the right, is designed to organize the network structure based on environmental concerns. When the network is set up this way, cabling can be run in proper routing and media for that environment. The centralized method on the left-hand side is costly and is inefficient when factory reconfiguration occurs. So if we take a look at the plant floor again, we see here a very typical network layout. Each network node or device makes a home run all the way back to the main switch in the micro data center. All connections are consolidated to one single switch. All network traffic as well goes through the same switch. So as most networks start out, this might work well for small applications, but as growth is required, this does not scale very well. Other issues are you run into cable length limitations. There's a risk of a single point of failure. There's no redundancy, and it can be very costly to upgrade for a major expansion. So, as with the zone environment, this allows for a segmented network. Some value points here on a segmented network is the ease of maintenance. That those big flat networks are difficult to manage and troubleshoot. With the segmented network, you can simplify your security management. You can segregate different traffic types, which helps create domains of trust. You can have improved performance. This will distribute traffic loading for efficient bandwidth utilization. And scalability. This provides a framework for evolving the overall network with predictive results. There is a section in the reference architecture, in the Design Information Guide, or the DIG, from Rockwell, on segmentation and how to deploy these types of segmented networks. So if you want to get into this deeper, you can reference this design guide. So alternatively, this is the zone layout. So with a zone layout, if you were to run fiber to each zone, you can actually reduce your cabling installation plan. You're able to localize network traffic to improve network resiliency. You improve your capability for network redundancy. One case might be running dual fiber paths to a single zone. And you can reduce the cost of a future expansion. So this integrated model, we've put that easy button there for you in the middle of the screen. It's an easy way to hit the easy button, and what you see is what you get in the box that is delivered. It includes all required hardware, fully integrated, tested, and documented. So what are the benefits of a zone architecture? What we've seen from our customers, as well as models that we've run, is up to a 40% reduction in material costs. Less cable to run, up to 18% reduction in labor costs. You don't have to run as much cable, therefore the installation goes faster. This is again based on a fiber optic LAN section model, but we've also seen similar results in the field. When deploying the integrated zone, your deployment time can also be reduced by 75%. So some benefits from availability, following the CPWE model results in a high availability system. For physical security, you can achieve that with that segmented network. Reliability, this design is thermally validated. We worked with Cisco and Rockwell Engineering. It's a validated network design based on a CPWE design guide. It includes a UPS or uninterruptible power supply, so it maintains the network under power surges. And it does provide a testable permanent link. Repeatable. Deployments are now repeatable versus a one-of-a-kind design for every deployment. Scalable. You now have a simplified expansion of production by adding additional zone systems. It allows expansion of downlinks within an existing zone system. And cost efficient. You now will have a smaller control room footprint. You'll have a reduced cost of cabling installation and a simplified deployment. So what exactly, when we say an integrated system, what does that mean? So a brief overview of what is in the integrated system. As mentioned earlier, there is a UPS within the enclosure. It is fully assembled and wired for this power supply system. This enables 100% uptime even during power failure. It is fully validated. This is a UL approved panel to UL 508. It has been thermally validated into our thermal lab. It has been tested for resistance to shock and vibration during shipment. So when it arrives at your door, it turns on and runs for your application. All 110-volt devices are housed behind a shield on the bottom of the zone enclosure, as you can see. And finally, it includes the Allen Bradley Stratix switches, which includes the Cisco switching technology with Rockwell software. So now I'd like to turn it back to Mark, who's going to talk to you now about these switches and their key attributes.
So thanks, Paul. So as Paul mentioned, one of the key components of the zone enclosure is the Stratix 5700 switch. And to optimize around implementation and ease of integration, this switch is built with Cisco technology, which offers a couple of key benefits to aid in quick deployment. By leveraging the Cisco operating system, which is often called the iOS, the Stratix 5700 provides a robust set of features that are compatible with the overall enterprise network. So from that, using a common network technology and feature interoperability easily reduces the integration time and risks associated with interoperability problems when you go to expand your network architecture. In addition, this technology provides a common set of deployment and management tools familiar to the IT professionals. So the utilization of common tools allows for the easy extension of items such as existing network service or security policies, as well as the optimization of people resources and assets, things like reducing the need for additional training to support multiple networks and different technology types. In addition to the overall network architecture compatibility, the Stratix 5700 has tools to easily configure the switch for a specific application. So again, focusing on easy deployment. This includes EtherNet IP, or the SIP interface, which we've talked about, and provides seamless communication to other EtherNet IP devices, is sort of the backbone of the architecture, and allows for premium integration to Rockwell Automation devices, Studio 5000, and our View products, which allows for use of familiar tools for the controls engineers who are doing configuration and management of a system. In addition, Express Setup allows for quick switch setup for industrial automation applications. So this includes items such as setting up network traffic prioritization, QoS policies, enabling loop prevention, or STP, alarm logs, and IGMP snooping. That's all done with a click of the button. Then in addition to that, smart ports are a set of recommended configurations which optimize each specific port to the device it is connected to, so to such things as controllers, drives, I/O, and other network switches and routers. So this simplifies, again, deployment and commissioning of the equipment without having to be a network expert. And then finally, the switch configuration is stored and backed up on an SD card. So much like you do with pictures on a camera, it allows for master configurations to be easily duplicated and moved from switch to switch. So now, Paul is now going to explain the savings this solution has to offer.
Oops. Thank you, Mark. So, why choose the integrated deployment? The integrated solutions reduce the design and deployment cycle, as can be shown by our little build up here on this slide. The steps in the standard deployment are no longer necessary with a pre-validated solution. Active equipment is delivered within an optimized physical layer for consistently high network performance. The system is pre-engineered and pre-tested and pre-validated. We're going to continue to say that throughout this presentation. And that segregated system enables, that power system enables IT or other personnel to safely access and manage the plant network to maintain the proper service level agreements. And with this deployment, with the integrated deployment, you're able to reduce risk and deliver up to 75% reduction in time to deploy. The other benefit is that what might take 10 purchase orders for all the devices and equipment within this zone enclosure can now come down to a single purchase order. This really improves the efficiency throughout the channel or the cycle of deploying a Stratix switch within the market. We have deployed the zone enclosure throughout the world globally. We do have a couple case studies we would like to speak to. One is a biotech plant. This was a greenfield or a brand new plant, and they were deploying a structured network. So they had several challenges. One was that the plant installation was for a process plant, so there was a mix of fiber and copper drops. As with most schedules, it had a very tight schedule at the very end. So they wanted the network up running as quickly as possible. So we recommended micro data center cabinets as well as numerous zone enclosures. The result was an on-time installation with no startup issues. They have now streamlined production and support utilities, and there was no data loss at any given point in time. So as this was a biotech plant, their key factors and requirements was to avoid downtime with a structured, validated solution. For them, if there was downtime, they would lose an entire batch, which could be worth up to $3 million. So uptime was their key here. The second case study was a food plant. This was involved with process monitoring for food safety. They needed to ensure proper temperatures were met. So the challenges here was for monitoring a process to ensure food safety and quality. So they needed a network infrastructure for this initial purpose and for use for other needs in the future. So they wanted to be able to grow and scale in the same magnitude. They previously had struggled with poor documentation and an architecture network in the past that caused a lot of downtime. So they worked with Panduit, and we helped them create a solid foundation for their plant network. They had issues in the past where an electrician might be troubleshooting and had unplugged a network connection. This resulted in several shifts of downtime. Because there was poor documentation, he did not realize what he was unplugging. They also had no structure to enable troubleshooting. It was all point to point. So for the result, we installed 4 zone enclosures. They started up without any problems, and the system goal to collect process data was achieved. So they now have a solid foundation for future projects and growth. So, in summary, today we've shown you how the solutions from Panduit and Rockwell Automation effectively deploy an Allen Bradley Stratix 8000 or 5700 in a validated pretest integrated zone system that enables your EtherNet IP network architecture, reducing downtime and cost. With this solution, you can effectively deploy an Allen Bradley Stratix 8000 or 5700 in a validated pretested integrated zone system, and you can enable your EtherNet IP network architecture. The big benefits are it reduces the design and deployment cycle. All the steps in the standard deployment are no longer necessary with a pre-validated solution. And that segregated system enables IT or other personnel to now safely access and manage the plant network to maintain service level agreements. Working together, we are creating more innovative and comprehensive offerings and driving integrated solutions that simplify, reduce risk, and accelerate adoption of EtherNet IP solutions and architectures. We do have some resources for you. We do have a lot of links listed on this page. You don't have to write these down. This presentation will be sent to you. But we do have an integrated network zone system landing page, so you're able to click on one click and get all the information in one page. Rockwell Automation also has a Stratix landing page for all the information and technical requirements of the Stratix. There's a nice zone architecture solution video if you'd like to learn more about zone architecture. We've spoken a lot today about the converged plant-wide EtherNet. This is on the Rockwell website as well, if you click on that link. And design tools. The integrated network zone system is already within the Rockwell Automation proposal works, as well as the integrated architecture builder. So I'd like to say a big thank you from both Mark and I for your time today. I know it is valuable, so I appreciate you breaking out to listen to this presentation, and I will turn it back over to Mark.
Great. Thanks a lot, Paul and Mark. It was a wonderful presentation. I'd ask everybody to hang on with us. We're going to have the Q&A session along with the final video at the end, and then the exit survey. In this part of the webcast, we'll take your questions. Stay with us if you're watching the archive because the Q&A is very educational as well. Type your questions for today's presenter in the Ask a Question box on your screen, and we'll get to as many questions as we can. They'll be answered verbally as we go through the Q&A session, and within a few days, the presentation and the Q&A session will be available for on-demand viewing. If you've registered, we'll send you an email when that's ready. You can also access the webcast via the Control Engineering homepage. On to our questions. So let's see. We have a question talking about convergence. Is the convergence that you're referring to recommending that IT and industrial automation technology are sharing the same infrastructure?
Mark, do you want to take that one? Devonshire?
Okay, Mark, could you repeat the question? I had a hard time
Sure, yeah.
hearing it.
Is the convergence that you're referring to in the presentation recommending that IT and industrial automation should share the same infrastructure?
So the answer is absolutely. I mean, that's the whole, or one of the key values, which is that there's a single network architecture that can support both enterprise level and manufacturing level kind of information and traffic, and they can all coexist on the same infrastructure all the time. So that is absolutely one of the key benefits, and Ethernet IP is one of the enablers for allowing you to do that, as it sits as a manufacturing-based application protocol and coexists with all the other existing application protocols that reside on Ethernet. So certainly the sharing of manufacturing data, video, enterprise-level data, and everything on a single architecture.
Good. Another viewer wanted to know the part number for the DIN patch box. Would you want to do that offline or offer that now?
I can do that. This is Paul from Panduit. That's our DIN rail mounting patch box. We have a copper version as well as a fiber version. The copper is CDPP8RG. The fiber version is FDME8RG. If you type in DIN rail mounting patch box at panduit.com, you can get that information as well.
Very good. On the what's the runtime of the UPS involved with this technology?
I'll try to answer that question. That's going to depend on which zone system you're referring to. Our large zone system can have two Stratix 8000s, full expansion modules up to 48 ports in a single zone enclosure. So it depends on how many switches and how many ports. But basically, I think we cover about, I think if memory serves me correct, it's on our spec sheet. I'll let you refer to our spec sheet on our website. That's going to have the information for the different systems for you.
Very good. Another question, what are the lead times to receive ZEARO? I'm not sure if that's pronounced as one word, or maybe explain what that is and then explain the lead times.
So I think that person's talking about a zone enclosure and as received. So right now we're shipping the integrated network zone system within 2 weeks.
Oh, very good. Does the UPS come with EtherNet SMP capabilities?
The Allen Bradley UPS does have that capability. It does have a, I believe it's a card. Mark, would you elaborate on that? But it does have that capability to connect into your network. From my knowledge, go ahead, Mark.
No, I would say I don't know the answer to that. I'd have to follow up on that.
I believe it does. For our zone system, we did not put it in. If you have interest in that, we do have numerous versions of the zone enclosure with different switches, different uplinks and downlinks, 5700, 8000. With a UPS, without a UPS, we could surely look at adding that port to that UPS for you.
Very good. How many ports can be achieved with copper or with fiber? And do you offer these with all copper and all fiber and in various combinations?
Yeah, we do. We, like I said, our largest one right now will handle up to 48 ports of copper downlinks, and that would correspond to 4 fiber uplinks for both connection and redundancy. We've got smaller versions that can go down to, I think, whatever the small switch size is, 6 or 8 ports. So we've got a wide swath of an offering in the integrated zone.
Good. Will Panduit or Rockwell Automation help us in laying out facility requirements and assist us in designing an architecture that we can build to as time allows?
Well, from a Rockwell perspective, we do have a network services group, and that's pretty much what they do is they work with customers on their specific needs and around network architectures, design, audits, and those types of things, and future solutions, which include top to bottom architectures and broad solutions, Cisco and Panduit, Rockwell-based solutions, and other devices as appropriate.
Paul, did you want to address that one?
Same question. Sorry.
Yeah. Can you help in laying out facility requirements, or would you turn that over to Rockwell?
I think Rockwell would be a great lead for that. Panduit does have a small services offering for the physical layer, but more importantly, it's the logical, looking at the logical first, and then converting and applying your physical infrastructure to support that logical architecture.
Good, and certainly the online resources like the Best Practices Guide can help with that as well.
Absolutely, yes.
Yeah, I would in general encourage everyone to take a look at the CPWE Design and Implementation Guide. It's a 400-plus page document that goes into detail in many different aspects that we just barely touched on relative to design and best practice implementations on many different aspects, including some of the the key ones we touched here, like network segmentation.
And last time I looked, there was no charge for that resource, right?
No, it's just posted up on our website. So, and it's referenced in the presentation material that we have included today.
Great. I'm sure people appreciate that. Another question, where do you recommend using redundant cabling in the zone switch level deployment architecture? The drawing appeared to show a strict star wiring topology.
Very, very good question, and it's going to depend on the customer requirements. We have done rings as well as stars with this topology, so either one is very successful. Again, it depends on working with the customer on what their goals are.
Good. Mark, anything to add on that one?
No, I think that's good.
Very good. When you talk about validation with a system like that, what would that include?
So this is Paul, and we work and have been working with Cisco for a very long time, and as well as Rockwell. And basically, we put the Cisco switches and the Rockwell switches through all the paces, and we're going to elevate them to their highest required temperature or allowed temperature, run full traffic, and put as many ports as we can, kind of the worst case, into the zone enclosure system, and ensure we have no bit error rate or failures of the switch. So that's what we do to validate a switch and a zone enclosure.
And that kind of robust testing would certainly be required in certain industries to have that level of assurance.
Yeah, with reference to the, again, to the CPWE design and implementation guide, for validation at that level, one of the key things is that everything that's in that guide has been validated and by Rockwell and Cisco in the lab environment. So everything that's recommended has been tested exactly, in both our labs, which we jointly support, and so it's validated on a component, architecture by basis for everything that's included in there. So there is no, sort of math-based components to that. It's all things that are documented and actually set up and tested in the lab.
Very good. Here's a question from a system integrator. Might there be an option to exclude the UPS in certain configurations? He says we have clients who don't have UPS protection upstream on their network and control, so the feature wouldn't be much of a benefit except perhaps for future use.
Yes, we do have that option available today.
So you could get it with or without UPS protection?
That's correct, yep.
Good. Please confirm that EtherNet IP is recommended for use between local rack with one processor and remote I/O banks. At one time, only ControlNet was suggested for this type of application. Does Rockwell now recommend EtherNet IP for communications between processor and remote I/O adapters?
I guess that one's mine. I think, I guess I'll have to read into the question a little bit, but I think it refers to redundancy associated with automatic switchover for multiple processors, so redundant controllers. And I still, at this point, I think the premier solution for that would be using ControlNet. However, there are components which are supported via Ethernet IP and an Ethernet-based solution for like redundant I/O and so forth. So we'd have to dig into that, I think, a little deeper and work with someone on a case-by-case basis to make sure we fully understand the application and the specific needs.
Right, a fair amount depends on a particular application.
Yeah, so I don't want to overcommit, I guess, in that area, and would suggest that we could work on a case-by-case basis to make sure we're addressing the specific application and could make recommendations on how best to do that.
Great, thank you. What is the difference between the Stratix 5700 and the Stratix 8000 or 8300 models?
So at a real high level, the Stratix 8000 is a full-featured managed switch platform that's modular. So there's a lot of flexibility in mixing and matching different combinations of fiber and copper ports, scalable up to 26 ports. And the 8300 on the same hardware platform is a layer 3 switch, so it provides routing capabilities. Usually sits above the access level switches. The 5700 sort of scales below the Stratix 8000 family. Again, it's very scalable. There's a lot more options so that you can better tailor your exact needs to the specific model of the 5700, reaching a lower price point if you don't need features. So again, it sort of scales down probably better for the OEM, and being able to again sort of match your specific needs more specifically against your application. The nice thing is that all three families are use Cisco-based technology. They have compatibility and common feature sets. Use the same tools for configuration and support and so forth. Have the same common Ethernet IP SIP interface. So it's very much a family-based solution across all those platforms. So it should be sort of seamless in picking the right fit for what you need.
Very good. How would you recommend deploying a system that's already a mess? We've all seen the control cabinet that looks like spaghetti. The product seems outfitted for a new application. What do you do for a retrofit?
I know, this is Paul, I know we've done some applications where perhaps they're expanding to a new cell or our new line is coming in, and we'll deploy that managed switch for that particular cell, understand how it works, and get comfortable, and then we go back and we start connecting into the areas that require help. Mark, do you want to add anything to that, or?
Well, I know one of the things that the network services team does on a regular basis is they do audits of the existing systems, where they'll actually come in and look at what you currently have and sort of figure out what's there, and be in a situation where we can provide a baseline of what this current situation is and what would be required to sort of, I'll say, get it back into shape, or get it in a situation where it's something that is more stable, is more future-proof relative to expandability and that type of thing. So that might be a good step. Let's figure out where you're at and what the situation is, and start looking at maybe the low-hanging fruit on, or how best to better align it with what your future needs are going to be.
Very good. Where would we find the tools that generate the switch configurations?
I'm hesitating only because I'm trying to make sure I fully understand the question. If in reference to the Stratix switches and my references to going through express setup and using smart ports where there's sort of macros that are already pre-done to optimize the switch quickly, those are all sort of defaults within the switch fabric, and they just come with the switch. So the intent is that quickly, without being an expert, you can add an IP address, add a password, click go, and have the switch configure itself for so the 80-20% rule where it's going to operate efficiently for an industrial automation environment. And then you can from there use some of the smart ports to further optimize ports again, which enables a set of macros that are already in the switch. You just need to enable them on a port-by-port basis to optimize to the specific device you're connecting to. So if that was the sort of the context of the question, all those macros, all those pre-configurations are already built into the switch, and you just need to determine which one you'd like to enable.
Great, thanks, Mark. Paul, would you like to give a quick 30-second summary of some key points?
Sure, Mark. Thank you. Thank you all again for your time. I know it is very valuable. Hopefully today you've seen some best practices, understand how to deploy a network properly for your manufacturing environment. How the solutions from Panduit and Rockwell Automation effectively deploy an Allen Bradley Stratix 8000 or 5700 in a validated, pre-tested, integrated zone system that enables your EtherNet IP network architecture, reducing downtime and cost. If there's any further questions, you may email me at paul.herbst@panduit.com. Thank you.
Great. Thanks for your questions, and thanks for our great speakers, Paul Herbst and Mark Devonshire, for sharing their time and expertise. Also, I'd like to extend special thanks to our sponsor, Panduit, for their generous support of today's webcast. In just a moment, we'll play a short video from our sponsor, and just after that, we will have, after the special video, if you would pause just for 20 seconds to compensate for various connection speeds, you can leave your browser open to take the exit survey, which will appear on your screen after the video. Taking the survey will help us create better webcasts in the future. Again, thanks for all the great questions. Those that we did not get to, we can email individually and follow up in that way. On behalf of CFE Media and Control Engineering, thanks for attending this webcast, copyright 2013 CFE Media. And now here's the special video followed by the survey.
Let's take a brief look at how a zone architecture compares to that of a traditional deployment. On the left is a typical industrial network deployment with cables being run from a micro data center directly to the control panel at the machine, which is a manner commonly known as home run. Usually, copper category cable is used throughout this deployment. Concerns experienced with this approach involve run distance limitations, the need for diagnostic test points, and flexibility limitations that relate to fixed pathways. As you can see, it's quite busy. On the right is the same industrial layout utilizing a zone architecture approach. Note the same layout of boxes, but the network shown in a different way. The green lines connect the micro data center to an interim zone enclosure designated by the Z. The black lines indicate the final connection to the control panels on the machine. Fiber optic cables are used to connect the micro data center and zone enclosures where the largest portion of data is passed, while the final runs to the machine are commonly performed with copper category cabling. Advantages of this approach include longer distances between devices due to fiber, greater layout flexibility as the industrial layout changes, and reduced operating expense due to the decreased need to run new cable and pathways to accommodate changes. please visit www.panduit.com or contact your distributor for more information.